All right, so how do we go about doing this one? Get rid of the fractions. How do we get rid of the fractions? Least common denominator, which is? Yeah, it's the only one that's there, right? X minus 5. You guys are so smart. Okay. So we're multiplying x minus 5 times all three of the terms on both sides. Okay? And x minus 5 times 1 is just x minus 5. And then x minus 5 times x over x minus 5. You know, you can think of it like that as a fraction if you want. What happens to those x minus 5s? They cancel, yeah. So all I get is x. The fraction, the denominator is gone. The same thing happens on the other side. When I multiply x minus 5 times 5 over x minus 5, the x minus 5's cancel. It just leaves me a 5. Does that make sense? Some of us were struggling with that a little bit when we started doing that last night. Okay, so the reason we're multiplying by the common denominator is to get rid of those denominators. Then we'll just have no fractions anymore. And it's a pretty easy problem to finish now. We're going to do x plus x, like terms, that's 2x. And then solve for x, get x by itself. So we get x is 5, right, Chase? Chase says, yep, we're done. We're good to go. You guys all agree with Chase? Mickey, you don't agree? Why not? Got to plug it in, check. What happens when we check the 5? When we put it there, we get 0. Without have a 0 underneath? No, so 5 really isn't a good answer. It's going to be no solution. So we got to check that. But we did everything right. And the 5 was what we got. But when we check to see if it actually works in the original problem, it doesn't. So we have to do that. Okay? Questions? So those are called rational equations. The ones we did Tuesday were called polynomial equations. And the answers to last night's are, number 15 was 2. Number 17, you got -4, but when you plug it in to check, it happens like this 5 did. It doesn't work, it gives you 0 in the bottom. 19, same thing happens. We get 3, but when we plug it in the original problem, we get a 0 in the denominator, so no solution for 19 and 17. 21 is 7 over 2, which is 3.5. And 23 is -12. That's a proportion. You cross multiply to do that one. Questions on any of those you'd like me to go over? So again, those were rational equations. We're looking at 4 types this week. So again, Tuesday was polynomial. Yesterday was rational. Today we call them what? Radical equations. So we got radicals in there, square roots in there. Okay? They look like this. So last week we worked on quadratic equations, solving those. That's when we had an x squared. And one of the methods that we did last week, we had 4 different methods of solving a quadratic equation, but one of the methods was the square root method. That's when we didn't have, we had an x squared and a constant. We didn't have the x part, the b part. Okay, so what we did is we got the squared part alone, right? And then what do we do to both sides? Once we got like x squared equals 64, what do we do to both sides to solve it? We square root it, right? Well, the same idea with the radicals. We want to get the radical part alone. Everything else on the other side, instead of square rooting both sides, what are we gonna do? How do we get rid of that square root symbol? Well, what's the inverse of square rooting something? We want to square, yeah. So that's what we're doing on these. We're gonna square both sides. Because we talked about this last week, the square root of something squared is itself, right? So on the left, I just have x plus 4 when I square both sides. On the right, it's 9. And then get x alone. Simple. But just like last night, we had to check our answer. Tonight, we have to for the radicals. You got to check your answer. So what's 5 plus 4? 9. Square root of 9. 3. It worked. Okay. Most of the time it works, but every now and then, what you get doesn't work. Sometimes we'll get 2 answers. And one of them works and one of them doesn't. So we always check on the radicals. Okay? Questions so far? So remember, the square root part, like this one, has to be alone on one side. Everything else has to be on the other side before you can square both sides. So what do I got to do first for this second example? Subtract the 2, right? Got to get the squared root part, that 2 minus x part, alone. So just leave it on the right side. Let's bring the 2 over to the left side. So I got x minus 2 equals the square root of 2 minus x. Okay? Now what am I going to do? I'm going to square both sides. Okay? What's the right side equal? 2 minus x. What's the left side equal? That's part of it. X squared is right. It's plus 4 though. But there's a middle term. There's 3 terms. Anybody know what the middle term is? Yeah, negative 4x. Okay, remember, x minus 2 squared means x minus 2 times x minus 2, right? So when you see a problem like the one up there in green, what do we call it when we multiply 2 binomials? FOIL, yeah. So first is the x squared, and last is the 4. But outside is negative 2x, and inside is also negative 2x. So that's where the negative 4x comes from, the outside-inside part. Now there's a quick shortcut way that I do these, and it always works. You take the first term and square it, multiply those together, and then double that, or times 2, because there's always going to be 2 of them when you FOIL. So negative 2x doubled gets me to negative 4x, and then you square the 2. This is, no matter, this is negative 2, you still get positive 4. Negative 2 squared or positive 2 squared, you still get positive 4. Okay? So again, square the x, multiply those 2 together to get negative 2x, and then double that answer, negative 4x, and then square negative 2 to get positive 4. That's a quick shortcut instead of writing it out and FOILing. Okay? Now, what happened here? What showed up? An x squared. So what kind of equation is that? The ones we did last week. What's their names? Quadratics. Before we solved last week's quadratics, we set it equal to 0, right? So we have to set this one equal to 0 before we can finish it up. So that means I'm bringing the 2 and the x from the right side over to the left side. So that it's equal to 0. Those cancel out there. So I got a 4 minus 2 is 2. Negative 4 plus 1 is negative 3x, and then my x squared. So there's my problem now that I have to solve. Now, we learned 4 different ways to do this last week, right? You can pick whichever way you want. My 2 picks would be factoring or quadratic formula. But it's your choice from here. This one factor is pretty easy. What are the factors of positive 2 that add up to negative 3? Negative 1 and negative 2, right? Negative 2 times negative 1 is positive 2, and negative 2 plus negative 1 is negative 2. So what are my 2 answers? 1 and 2. And I'm all done, right, Kennedy? That wasn't a very confident yeah. I was like, yeah? You think so? Okay. You guys agree with Kennedy? Why not? Oh, supposed to check, aren't we? We don't agree with Kennedy. I can't believe it. Kennedy's always right. But yeah, we need to check. So, we put a 1 in for x. I just put a little check mark for the check. And then 2 plus the square root of 2 minus, and I'll put a 1 in for x, right? What's 2 minus 1? 1. What's the square root of 1? 1. What's 2 plus 1? 3. Are those equal? No. So the 1 doesn't work. We better check the 2 to make sure. It probably does. Usually, at least if you have 2 answers, at least one of them works. But let's make sure. So we'll check it in black here. Now we're putting a 2 for the x, so I put a 2 there. And then right there, that x. What's 2 minus 2? 0. What's the square root of 0? 0. What's 2 plus 0? 2. Does 2 equal 2? Yeah. So the 2 was a good answer. Questions? So this one, we had to move that 2 over first, so we had the radical part isolated or alone. Then I can square both sides to get rid of that radical sign. Sometimes you'll get multiple radicals. In a problem. Okay? So same rule. One, in this case, one of those you got to get alone on one side so you can square both sides. Okay? And it doesn't matter which one. So since we're subtracting that one, I'm going to move it over so I have addition. So I'm going to move that one over. So now I have x plus 1, square root of x plus 1, sorry, on the left, isolated. And then I've got 1 plus the square root of 2x minus 5 on the right. So to get rid of this radical on the left, I'm going to square both sides. So the left just becomes x plus 1. Because the square root and the square, they cancel each other out. Now over here, it's like the one we just did. I got 2 terms, right? I had 2 terms there. I got 2 terms now. So the shortcut again, first term squared, Multiply those together. What's 1 times the square root of 2x minus 5? The square root of 2x minus 5. But I gotta remember to double that, or times 2. So there's 2 times the square root of 2x minus 5 for the middle term. And then you square this. What's the square root of 2x minus 5 squared? Square root of 2x minus 5 squared. 2x minus 5. The square root and the squared cancel. Just like it did over here, right? I still got a radical though. So I got to get that one by itself. And then square both sides. So it's like I got to do it twice. When you have 2 of them, you got to do it twice. All right, so I'm going to take the 1 over the 2x over and the 5. Okay, you with me? Questions? John, you okay? Mm-hmm. All right, so cancel. So I got this 2 times the square root of 2x minus 5. We're just going to leave this 2 here with it. Because if we divide by 2, then we get some fraction. Do we want to mess with fractions? No. So we're just going to leave it over there for now. This 1 goes away. What's 1 minus 2x? 1x minus 2x. Negative x. And then I got the plus 5. Okay. And what we'll do is the same thing we did already. We got to get rid of that radical. So we're just going to put parentheses around each side and square it. So this is different. It's 2 times that. So all I got to do is square the 2 and make it a 4. I don't have to FOIL this. There's no plus or minus between them. See the difference? The 1 plus, and this is 2 times. Okay? Here, I'm thinking about FOILing. Here, I'm just squaring this and this. All right? This one I'm thinking about FOILing. Negative x times negative x would be positive x squared. Negative x times 5 is negative 5x. Doubled is negative 10x. And 5 squared, positive 25. 2 squared is 4. Square root of 2x minus 5 squared is 2x minus 5. So it looks like that now. No more radicals. That was the goal. Now, what do I do? Liam, what do you think?
Probably put the 4 into 2x minus 5.
Yeah, distribute the 4. Cody, now what? Yeah, but we would subtract, right? And move the 20. It's a quadratic, so we're going to set it equal to 0. So we got our 0 on the right. 25 and 20 is 45. Negative 10 and negative 8 is negative 18. And then our x squared. Again, from here you can solve it whichever method you want or like from last week, but it factors. Nini, what's it factor into?
I don't know.
Ooh, who was that? Myers? Got your back, Ashton. Yeah, negative 15 times negative 3 is positive 45, right? And negative 15 plus negative 3 is negative 18. So what are my 2 answers? 15 and 3. And I'm all done, right? No?
Yeah, you're done.
Gotta check.
No, we always got to check, right?
No, if you don't,
All right, so for the check, remember it was 15 and 3, right? Okay.
Yeah, I wrote this down.
You ready for it?
Yeah, right now.
All right, we could, except we got one more to talk about tomorrow. All right, so 15 plus 1, the first one, minus 2 times 15 minus 5 equals 1. What's 15 plus 1? 16, square root of 16, 4. 2 times 15, 30, minus 5, 25, square root of 25, 5. 4 minus 5 is 1, right? No.
No.
It's negative 1, right? So, is 15 a good answer?
No.
No. All right, let's try the 3.
Three grand.
3 is probably going to work,
Yep.
but let's check it. So 3 plus 1 minus 2 times 3 minus 5 equals 1. So what's 3 plus 1? 4 square root? 2. 6 minus 5, square root of 1. 2 minus 1, 1. Yeah, that worked, right? So, number 3 check. All right, so that one takes a little longer. It's not anything hard for you. Just takes a little more time because you have to square both sides twice. Okay, when you got the double radicals in. So get one on each side. The one that's all by itself without anything else, square. If there was nothing here, it'd be a lot easier. Then I just square both sides and the square root symbols go away, right? You know, if this one wasn't there, all you have to do is square that, which is 2x minus 5. That would make it a lot easier. But I usually don't do that for you. Okay? So get the radical part isolated, square both sides. If you get an x squared, set it equal to 0 and solve it like we did last week. If you don't get an x squared, just get x by itself. 5 problems. Good job.